Hello and welcome back everyone to this webinar series on applications of remote sensing based evapotranspiration data products for agricultural and water resources management. This is the third and last session today. Earlier we had overview of OpenET data and EcoStress ET data. Today we will focus on exercises where you will have chance to work with these two websites to access and download EcoStress and OpenET evapotranspiration data. Just one point to note here, homework is posted on ARSET website and answers must be submitted via Google form. The links are available here. The homework is due on June 29th. After the webinar is completed, you will receive a certificate of completion if you submit the homework by the deadline and also if you have attended all 3 live sessions. So what we're going to do is we will have very brief summary of what we saw, some main features about OpenET and EcoStress ET. Then we will have some review of unit conversion of EcoStress ET. As you recall, EcoStress ET data are available in watts per meter square and OpenET available in millimeters per day. So what we're going to do is see how watts per meter square can be converted to millimeter per day evapotranspiration. Then I will demonstrate both these sites, OpenET and Appear site, and we will have step-by-step exercises where you can go through these sites, choose some areas or points and access data, download it, visualize time series. It's not involved as what we saw last week from Gregory Halverson. It's not very heavy on analysis. It's mostly so that you get experience and you can navigate through these websites and look at the data sets. It's just so that you get feel for how to use this data. So in future, if you are looking for detailed analysis, at least you know how to navigate through these websites and download data. So to summarize our overview and access of OpenET data that we saw in week 1, OpenET is calculated using remote sensing data and 6 different models. So on the website, ensemble mean ET values are available and also ET data from individual models are available on the site. These data are available over the Western US. The special resolution is 30 meter. Currently, the data are available on monthly basis and annual cumulative data are also available. They are producing daily data and they will be available in near future, as we heard from Forrest Melton in week 1. OpenET will be extended to cover the entire US in near future as well, and there are efforts underway to expand this data internationally. As we will see, potential ET and graded precipitation data are also included along with ET data on the OpenET portal. As for EcoStress ET, that is calculated using EcoStress surface temperature and emissivity data, so based on energy balance, and it uses Priestley-Taylor jet propulsion laboratory algorithm. The reference is given here. So PT-JPL ET data are global, coming from EcoStress, and they are available at 70 meter resolution. Daily ET estimates and evaporative stress are available from Appears, as well as instantaneous ET is also available. Both OpenET and EcoStress ET data are validated by using the eddy covariance technique at FluxNet sites, and the reference is given here. For the PT-JPL ET algorithm, here is the reference where it is described in detail. So next, let's see how to convert watts per meter square to millimeter per day. PT-JPL EcoStress ET is in watts per meter square, which is energy that is used for evapotranspiration of water. So per day, there are 86,400 seconds. 1 watt is 1 joule per second. So it's really rate of energy joule per second. So 1 watt per meter square is 86,400 joules per day. This is for meter square now, per unit area. As we know, density of water is 1000 kilogram per meter cube, and latent heat energy of evaporation is 2.45 to 10 to the 6 joules per kilogram of water. This is at actually 20 degrees Celsius temperature. So this has temperature dependence, but it is more or less 2.45 to 2.5 megajoules per kilogram. And this is the energy needed to evaporate 1 kilogram of water. Based on this density, we can say that 1 kilogram per water would be a volume of 0.001 meter cube, or it is 1 millimeter of water depth over meter square of area. So that's the conversion that we use. So for 2.45 10 to the 6 joules energy is required to evaporate 1 millimeter of water. So in millimeter per day per meter square, if we want to convert watts per meter square to millimeter per day, you will first convert that watts to joules per day, and then it is this in energy joules required to evaporate water of this volume or this depth. So when you work through this factor, you get evapotranspiration in millimeters per day. And you can look at this document here from FAO. It describes how this conversion is done. So with that, what we're going to do is I'm going to demonstrate quickly OpenET site as well as Appear site, which you have already seen, but we're going to focus on specific regions and see what the information is available, how to download, and then there will be step-by-step exercise that you will have time to work on. We will stay online so you can work with the data, and then at the end of that, we will have question answer session as usual. Some of your homework questions are based on the exercises that you will be doing today. So if you cannot finish the exercise during this time, you can take this week or next 2 weeks to work on those exercises and then do the homework. So I'm going to stop sharing my screen and go to OpenET website first. So start with the OpenET data portal that we saw in week 1. And let's walk through this Explore Data link. Go through Explore Data and you will see field summaries and gridded data. Let's start with field summaries so we can see individual fields. Here's the Western US where the data are available in inches. Let's look at the SI units or convert it to millimeters. So here's the scale. Let's turn the cities on so we can see where we are. Here is the select year. You can select from 2016 to 2021. Let's keep 2021 for now. Variable is ET. You can have raster view or field view. Let's just have field view for now. And what we can do is now zoom in and pick a field where we are interested in. So for example, let's look at, this is Kansas, where a lot of wheat and other crops grow. So let's focus in here. Zoom in. When you go to about 13 or 14 zoom factor here, you will see that you can see individual fields. And when you click on any of this field, it shows the field boundary and the graph appears on the right hand side if you can see. It shows on top total accumulated ET for the year for this field, area of the field in hectares. It has a crop type. Here it is corn and soybean. Y-axis shows ET in millimeter and x-axis shows month. So you can see monthly ET for this particular field. This is for 2021 because that's the one we chose. When you move here, the graph changes as you can see, and it shows the same information, total ET, area, and the time series for this particular year. You can see what the range of ET is for all these fields, and here you can see this is miscellaneous annual crop. This is miscellaneous annual crop. Here is corn and soybean. So you can see what kind of crops and what evapotranspiration is occurring this year. When you click on any of these fields, say let's click here, it works through all data from 2016 to present and provides time series of ensemble mean ET based on these models. And range that is found in these models, you can check that by clicking here on range. Note here that the about crop type and area and field ID are given here. Also note that the region we focused on, that center latitude longitude, not of the field, but the area that we are in, they're given here. This is the longitude, this is latitude. You can look at PTJPL, it's here, and it comes up. You can look at all the models if you like. That decides what range is there. When you go through this, it shows value for this particular month for this field from a model and ensemble mean. So you can click on download data, and you can download images in JPEG or PNG format or as CSV files. The time series can be downloaded as PDF document or SVG vector image. You can look at cumulative data, annual cumulative data. It shows for each year and each month as it progresses. And when you go here for each month, it lists cumulative evapotranspiration. This can also be downloaded the same way. Note also that there are additional variables. ET0 is the reference ET that you can plot. For monthly also, you can look at additional variables such as ET0, and this is a reference ET, and NDVI also can be seen. So what you want to do is maybe turn other plots off and look at NDVI and ET0. So that contributes to ET, and that you can see here. ET fraction is from each of this is basically fraction is the realized fraction of reference ET that actually evapotranspirated. So that's the fraction of ET that you can see. So what was the actually potential, and then how much actually evapotranspiration occurred. So this is how basically you navigate through this and download data that you can then work with other hydrologic component for each month if you like for this particular field or this area. Let's go back to explore data and look at the gridded data. And I'm just going to randomly zoom into some area. Here I want to show the feature draw custom area. Here also let's turn the cities on and change the units to millimeter. Here we can look at 2021. And let's draw a rectangle. Notice that if I make a big rectangle, it tells me area selected is larger than 1000 hectare. So the limit here is 1000 hectare. So the data you choose, the polygon should be less than 1000 hectares for gridded data. So let's look at this area and run time series. Again, you will see that this is monthly data, this time series, then you can also look at cumulative data. It's the same, but now for gridded data, and now you have not just one field, but area which is less than 1000 hectare of your interest. It could be your watershed, it could be your local municipality, or where water has to be managed. You can pick that area. One thing to note here is that the polygon that you draw, either polygon or rectangle, whatever you draw, you can save those coordinates on clipboard. So important thing is that you save those and it gets copied onto clipboard, and everything else is the same. You can download and look at other things. Now look at the additional variable. Here, in addition to reference ET and NDVI, you also have precipitation data available from GridMat. And so this particular area, precipitation also is shown in millimeter and ET. You can see how the phase is different between max precipitation and ET and how they vary. So you can actually take difference and see for each month where precipitation minus evapotranspiration, how it changes. If you save it as CSV file, you can take that difference and see water deficit or water excess for this particular month for this year. So this is just the basic navigating through OpenET data, looking at it and downloading it. Your first exercise has two parts that will cover field level ET access as well as choosing an area. You can choose area of your own interest, although it guides you through. Look at Nebraska and California, but basically you will be going through the similar processes and note how if ET varies from month to month, year to year, with crop types, with region, you can analyze this just visually. So now let's go to EcoStress ET. To access EcoStress ET, we saw last week that we use the Appears website. So once you go there, sign in with NASA Earth data, username and password. Once you do that, you can access data and download data. You can explore. Here, let's extract data. Last week, Gregory Halvorson showed how to extract area data and analyze it because it's in GeoTIFF. You can make time series, you can plot data, make averages. Here, for demonstration purposes, I'm going to use points because that's easy to analyze now without help of, say, QGIS at this point, but it gives you some idea of how to go to this website and get data. So let's pick point. Once you pick that, you can start a new request. And here I'm going to call it point 80. Just name to identify your request. Once you do that, you can either enter points here. So, or if you have many points, many coordinates you are looking at, you can have a CSV file with list of latitude, longitudes, and here is that is described here. Or you can have, if you want an area, you will have to look at you can have to form a GeoJSON or JSON file, or have to have a vector file. So if you recall, we just had looked at OpenET and we focused on this gridded area in Kansas, and we saved those coordinates on clipboard. On Mac, if you press Command and V, or on Windows machine, if you click Control and right click, then you will be able to paste those coordinates that you saved on clipboard. And here are the 4 corner points of the rectangle that we drew on the OpenET portal. So I'm going to use these points in EcoStress window, where here I'm going to enter all those points, latitude, comma, longitude, as shown here. And I've already done that. So let me go to this site where I've already put in this data, coordinates. Here, let's, for example, have 2021, July 1st, and here we can have 2021, July 31st. So 1 month, here it shows you have 4 points that you put in here. You can zoom in and look at the points where they are. Here is the data selection. So let's say EcoStress, and multiple options are there. We are interested in PT, JPL, EcoStress, evapotranspiration. So click on that. That also has multiple options, multiple parameters. As you can see, it has canopy ET. This is ET daily total. This is what we will pick by plus. You can also have uncertainty. There is ET from soil, but we are going to look at total evapotranspiration at 70 meter resolution from ISS EcoStress. Once you do that, you can submit this, and you will get a message here. The point sample request was successfully submitted. Now you will receive an email when this data are ready. Or you can check, you go here on Explore, and here's the point ET that's pending for now. Once the data are available through this site, they are extracted, you will see it is done. Here it will say done. Once you see that done, you can click on this download arrow and it will download the file as CSV file. So what we're going to do is, while we wait for these points to download, I'm going to just show what I already had done. This was over California. I had picked 4 points, and this has all the coordinates, and that file is already I have downloaded as CSV. So I'm going to look at these 4 points. What it shows here is latitude, longitude of those 4 points. These are the dates. As you can see, it's July 2021. Between 1st and 31st, there were 4th, 8th, 21st, and 28th, 4 overpass over this particular region or points that we picked. It gives you EcoStress orbit numbers, scene ID, build ID, and orbit correction was done or not. And these are the evapotranspiration data, and they are available in watts per meter square, as we saw. So let's, once you have these, you can see at each point how much evapotranspiration was there. We can find average of this, which is already here. I've done that. And so that's the number that is average. So what does that mean? It is average over 4 points and average over for this month. So it's actually watts per meter square daily data averaged over this month and averaged over these 4 points. And now you can take these ET in watts per meter square and convert it to millimeter per day by using the factor that was shown in the demonstration and in the presentation. So basically, this allows you to save EcoStress data, convert unit, do some analysis. This is just for your information that this is how you can look at point data. We already saw last week how you can look at area and look at geotape images and how to analyze those. This we are doing so if there is any particular field you are interested in, you can look at that and enter the point and look at ET. If you have precipitation for that area, you can analyze that as well. And so what you will do next is go through the exercise. Pretty much all the steps that we went through, you will go through. We have half hours, we have some time. So what I'm going to do is stop sharing my screen and show the exercise that you will be working on. And you can go through the steps and do the exercise on your own. There are questions at the end of each exercise that you can answer. And some of those questions are also in your homework. So here is where I'm going to stop sharing my screen. So you can look at the exercise is available from the meeting page that you can download. Uh, so we have lab time or work through this basic exercise for next 30-35 minutes or so. You can finish the exercise later on if it's not done. It's basically going through the same steps, but it allows you to navigate through the websites and look at the area of your interest. For ecostress, we focused on the same in the Western US, but if you're interested, you can also look at other region from other countries if you're interested. So you can follow the steps in the exercise, but you can still choose the area of your interest and work through that. So what we're going to do is we'll have some quiet lab time. We'll be here if you have any questions. And just in about half hour, 35 minutes, we will start our question answer session as usual before we conclude today's webinar. So we'll just take a few minutes. You can look at the exercise. Please download that and you can start working on it. So in the handout section of this meeting, you will see ET underscore week 3 underscore exercise. It's a PDF document that you can download and open. All the steps are given there, basically going through the same steps that we did in the demonstration, but this allows you to work with the data and pick your own region of interest. So while you are working on the exercise, please make sure that you convert the ecostress ET to millimeter per day. That's one of your questions. And that way you will be able to see how it compares with open ET data in the polygon that you chose. And the reasons why they would or they wouldn't agree. And so we can talk about that later. So we're just about to start with the question and answer session. You can enter your questions in the QA box and we'll try to answer them. If we cannot get to them, we'll post the document online so you can see the answers. Before we start with that, here's just the information. We have contact information as well as our training webpage where all the material is available. This is the ARSET website where you can see upcoming trainings and other materials posted there too. Also, please check out our sister programs, that is Develop and Surveyor. You can get more information about these capacity building programs by going to these links. And so with that, we'll start with question and answer session. What validation measures are made to check the remotely sensed ET against ground-based observation? What approximate percentage of the covered area in open ET is validated? What were the main instrumentation network used to validate the ET? So we'll provide the details after checking every step, but as was shown, there is a paper, FluxNet data were used to validate OpenET data. What fraction, that wherever the FluxNet data are available, that's where they were validated. And in the presentation, there was a reference to that about the FluxNet data, where the data are available. Um, they are available here in the US, also internationally they are available. So EcoStress data are also validated with some of the FluxNet data. And Gregory, I think, is here online. If you have any information to add about EcoStress validation, please go ahead and do that. Okay. The next question is, if the latitude and longitude coordinates of the 4 points are provided, shouldn't the selection geometry be a quadrangle instead of a point? Yes, that is correct. The whole idea was to just look at a few points. Last week we had detailed analysis from Gregory Halverson, who showed how to pick an area and get the geotiff raster for that area and do analysis. Here, to quickly look at the values, we picked a few points and just checked the number out. So that's, and if you're interested in a particular field and if you know the let lon, this is the way to do it. You can just enter that let lon and get the data. And if you have any instruments you want to compare with, or if you have rain gauge or other weather station around where you want to use this data along with, you can get the point data. So that's the nearest point, so from your let lon that you provide. Question 3 is it possible to download multiple files at once from ARSET? Yes, it is. You can order multiple files. Once the order is done, and when you get the notification back, when you explore what's done, what is completed, when you click on that, if there are multiple files, you can click on individual file to download, or you can down them all by using in zip file format. So it's possible, yes. What does PTJPL stand for? So that is Priestley Taylor JPL, or Jet Propulsion Laboratory Algorithm. And here's the reference given for the paper. Thank you, Sean. We saw that in the presentation also. There is a link to ATBD document for EcoStress specifically that you can go through. That original PTJPL was using MODIS data. It's been changed to use EcoStress ET data, and so you can look at the ATBD document to see that. Question 5 is, what areas, countries, continents is the data available for? As we summarized, EcoStress ET is global. It's available everywhere. And OpenET is available for the Western US. Why can I not select products under appears point ET data after I have chosen the date in 2021 in June as the presenter showed? I am stuck on that step. Not sure why you're not getting data. If you're getting any error, and if you can let us know, we can help with that. Or if you can send your screenshot, maybe we can help. If you follow the step, if you put the coordinates in that right-hand side window, latitude, comma, longitude, that's the format, and pick start and end date, then you should be able to get the data. I'm not sure what the problem might be. Can you please let me know where let long is shown in the field map? It's in the URL on the top. In exercise 1, part 5, which year had maximum cumulative ET in Is that correct, or do you mean the largest month value in 2021? Yes. So sorry, if that is true in 2021, which year had maximum cumulative ET? So not in 2021. In general, which year had um, most cumulative ET in December? It should be. So at the end of year, when you look at uh, which year is the one. So that say we need to change that in the text. Please, can you remind me where the crop type should be found in the OpenET browser? So if you click on the field, you will see where you see the graph. Crop type is given there. Um, if you click and you get this multi-year time series, on top it says crop type. Question 10 is, why does appears bring an image when you select area after submission when you download data? Not sure if I understand the question. Why does appear bring an image when you select area after submission when you download data? I'm not sure. If you are downloading geotiff image, I'm not sure exactly what the question is. If you can clarify, when you download the data, what exactly do you get? Can we validate? Question 11 is, can we validate our model ET with eco-stress data? You can compare it. Eco-stress data are validated with FluxNet where the data are available. So again, ATBD would have more information about that. And you can, one thing to do is you can see how different they are if they're not exactly matching. Are there any biases and errors, or if there is systematic bias, you can perhaps attribute it to either model or both, eco-stress in both. But yes, I think you can at least compare and see where your model, how close your model is with eco-stress ET. Yeah, so like Gregory Halverson, Gregory, you can unmute yourself. Um, what he's saying is that it wouldn't be a validation unless you're comparing directly to ground measurements. So it's more like comparing your data with eco-stress from your model, not validation. Yeah, so as for question 10, I guess as Gregory said here, and he showed last time, that if you get area queries, you get an image. For points, you get just a table or numbers for each point. So today's recording will be available in 48 hours for your view. The homework is due on 29th of June via Google Form, and you have the link on the website and in the presentation. So just to repeat what we talked about in the first week, evapotranspiration is the second largest component of the hydrologic cycle when you see evaporation or evapotranspiration next to precipitation. So it's pretty important. And you cannot, FluxNet is a point measurement. It's like on tower. And so instruments, they cannot provide direct measurement of ET. It's still derived based on eddy covariance. So Okay, question 12 is, how can I get the coordinates out from the clipboard using a Mac? Don't know where the clipboard is, but the image says the coordinates were saved. If you go on Mac, press Command V, then go open a document, say, and press Command V, then you will see the coordinates. Question 13 is the average ET star is desired? Yes, this is the equation. So ET in watts per meter square multiplied by it would be like 0.086 megajoules divided by 2.45 megajoules. Yes, that's the equation. That's correct. Do you know about these kinds of initiatives in other places around the world, or is it just for the US? As we talked about in session 1, OpenET right now is for the Western US, but they are trying to expand it to the entire US, and then initially, I think, for Australia and Brazil. And as more in situ weather data become available for other countries, they may extend it there too. EcoStress, because it's on International Space Station, data comes from there. It covers global area. So EcoStress data are global. We just focused on the Western US for our case study of exercise, but you can go ahead and do the same steps from last week and today's exercises. You can look at other regions. Okay. Next question is if there is less availability of flux tower derived ET data, then how can model ET be validated? Any other solution than flux data? For validation, you do need flux data or ground-based validation in ground-based observation. So other than that, what you can do is from different sources, if you are getting ET data, you can look at the spread compared to your model and try and understand the differences. But I think for validation, you do need surface-based observation data. Question 16 is for OpenET, when we are looking for locations in Nebraska, is it possible to search them directly? You mean with latitude longitudes, or I think you basically go by the portal. You look at visually, zoom in, and pick the region. Where can we find information on how the crop types in OpenET data were identified? So that comes from USDA, and if you go to OpenET page, that information is there. We will provide that in this document. Question 18, for agricultural yield prediction, could ET be estimated on GEE with Sentinel-2? So Sentinel-2 would have surface temperature. You can have surface temperature from Sentinel-2. So you can, in principle, if you have Sentinel-2 data, but the algorithm you have to train for Sentinel-2. I don't think GEE has that facility or script or app that can do that. But Sentinel-2 bands are pretty close to Landsat bands, and you can use those to get surface temperature.
And sorry, Amita, Sentinel doesn't have surface temperature, or at least Sentinel-2 doesn't have surface temperature. It's just shortwave multispectral, so you can get NDVI and albedo, but not surface temperature.
Question 19. This might be more of a science or research-based question rather than based on the session today. Can ET from water cycle be correlated to carbon cycle in any way? Any research articles would be much appreciated. I don't remember on top of my head. I can search for those, but correlation would be possible because they both depend on vegetation, right? Well, carbon is related to amount of vegetation, or an ET, of course, depends on that too. So it's possible, but we will search for some studies and see if we can find any. So Gregory Halverson says Sentinel-2 does not have surface temperature. No, but the bands that can provide surface temperature, I think it has. If it doesn't have thermal IR, maybe not, but we'll check. But Gregory says no, it doesn't have thermal data, so no, Sentinel-2 cannot be used. I stand corrected. I think yes, Sentinel-2. If there were thermal IR, you get higher resolution than surface temperature. That would be great. Okay, so if there are no more questions, we really want to thank you for attending today's session and this webinar series. Today we conclude this webinar series, and you have homework to work on. We want to thank our guest speakers, Forrest Melton and Gregory Halverson. Both did wonderful job in providing information about OpenET and EcoStress ET. You have their contact numbers as well as ours. So if you have any more questions, you can send us emails. And we also want to thank our entire ARSET team. That's Jonathan O'Brien, Sarah Pashel, Sean McCartney, Selwyn Hudson-Odoi, Brock Blevins, and Erica Podes. They all helped in organizing this webinar. So thanks everyone, and thank you all for attending today's session. We will try and find information about the questions that we could not answer today, and all the material will be posted on our website in very soon.